All right, so today we're going to do some more exponential curve fitting. But before we do that, I want to show you a different method for finding the equation of a line when they give you 2 points. So prior to this, for finding the equation of a line given 2 points, you would always calculate the slope, and then you would use one of your points to calculate the b value. But what I'm going to show you today is that you can actually find the equation of a line by creating a system of equations and using either elimination, substitution, or equal values. And I will tell you this method, when you create a system of equations, the most efficient way to do this is by using elimination. So let's look at problem number 92. And Mitchell is working on his algebra homework. He wants to find the equation of a line that passes through the points 5, 15, and 3, 7. That's those 2 points right there. Mitchell says that we can write the equation of a line in y equals mx plus b, but we also know the points 5, 15, and 3, 7. So we can substitute the points in and create a system of equations. So what he's saying is he's going to plug in 5, 15 for xy, and then in the other equation, he's going to plug in 3, 7 for xy. And what he's actually going to do is he's going to find the values of m and b. So let's look at what Mitchell is going to do. So we're going to take the points 5, 15. We're going to still use the equation y equals mx plus b, but now instead of plugging in finding slope, we're just going to plug in, oops, sorry, not that. We're going to plug in our x value, and we're going to plug in our y value. Let's erase that right there. All right, so here's what's going to happen. I've got 15 is my y, is equal to m. My x in this problem is 5 plus b. For my second equation, my y value is 7. M, my x in this case is 3 plus b. And now here what I have is a system of equations. And what you'll notice is that you have a 1b in both equations. And so the easiest thing really to do is to use elimination and take one of the equations and multiply it by -1 to get b. So I'm going to take this equation, I'm going to multiply by -1 on this side of my equation. I'm going to multiply by -1 on this side of my equation. So my top equation is going to stay 15 equals, instead of writing m times 5, I'm just going to write 5m because we know it's the same thing. And then my bottom equation is going to turn into -7 equals -3m minus b, and then just like always, I'm going to add these two equations together. All right, now when I do this and I add my equations together, my b's cancel. 15 plus -7 is 8. 5 plus -3 is 2m. When I divide both sides by 2, I get m equals 4, and there is my slope. Now that I've calculated m, I can also now calculate b. So why don't you take a minute, either choose the top or bottom equation and calculate b. All right, so hopefully you were able to calculate b. I happened to plug m in to the bottom equation just because the numbers were smaller. So now my equation of my line is y equals 4. That's my m value, x minus 5. There's my b. So just know, if you prefer using system of equations to find the equation of a line, you now know that that's an option for you. If you want to stick to the traditional way and you want to do finding the slope using change in y over change in x, and then using a point to find your b value, that is still very valid and you can still use that. All right, now let's move on. Okay. In this problem here, they tell you that Mitchell wants to use the idea of using a system to find an exponential function that passes through the points 2, 16 and 6, 2, 56, okay? So they ask you what's the general form of the exponential function that has an asymptote at y equals 0. And we all know the exponential function is y equals a times b to the x. And we know in this situation, a is our starting value and b is our multiplier, okay? So now the idea is to use the points 216 and 256 to write a system of equations. Well, again, they are x and y. So I'm going to show you all three different ways to solve this system of an exponential function. First using equal values method, then using substitution, and then finally using elimination. All right. First things first. I'm going to move this over. We're going to start over here. We're going to use equal values. Okay, so I'm going to write my two equations. My first equation that I'm going to write is going to be using the point 216. I'll put my points here so you know what points I'm dealing with. 216 and 256. All right, so my first equation is going to be 16 equals ab squared. I plugged in 2 for x. I plugged in 16 for y. My second equation is going to be 256 equals ab to the 6th. Now, in order to use equal values method, I need two equations that have the same variable alone. Both of these equations have an a value with a coefficient of 1. They're just 1a. So the easiest thing to do is to rewrite each equation in a equals form. And in order to do that, I have to divide by the b value and its exponent. So this top equation, 16ab squared, if I divide both sides by b squared, I get 16 divided by b squared equals a. If I take the bottom equation and I divide both sides by b to the 6th, I get 256 over b to the 6th equals a. I now have two things that are set equal to the same equation. It's just like when we have y equals and y equals. So if this value here is equal to a and this value here is equal to a, then those two values in fact must be equal to each other. So I'm just going to set them equal to each other and then we're going to solve from there. So I've got 16 over b squared equals 256 over b to the 6th. Now, in order to eliminate these denominators, I'm going to do something that you can only do when you have two fractions set equal to each other. So what I'm going to do is I'm going to cross multiply. That means I'm going to take 16 and multiply it by b to the 6th. That's going to give me 16b to the 6th. And I'm going to set that equal to when I cross multiply going the other direction here, which will give me 256b squared. Now, I got to get all my b's on one side. I got to get all my numbers on the other side. So I'm going to divide both sides by b squared. The reason I chose b squared is because I know that when I divide both sides by b squared, my b's are going to be left in my numerator. So I'm going to start here, divide by b squared, divide by b squared. These two b squareds cancel out. I have 16b to the 4th because 6 minus 2 is 4. Equals 256. Now I have to divide both sides by 16. And I end up with b to the 4th equals 256 divided by 16 is 16. My last order of business here is going to be to take the 4th root of both sides. When I take the 4th root of both sides, I end up with b equals 2. And now that I have a b value, just like with anything else, I can take that and plug that into an equation and I can solve for a. When I do that, I'm going to pick the equation with the smaller exponent. So I'm going to take my b value and plug it into 16ab squared. So I've got 16 equals a. Instead of b, I've got 2 squared. So I've got 16 equals a times 4. I'm going to divide both sides by 4, and I get a equals 4, which means my final equation here is now y equals 4 times 2 to the x. And I've just now written an exponential function given 2 points using the equal values method. All right. I'm going to show you how we use substitution. So once again, I'm going to start with my same 2 equations. So let me just label this substitution. I'm going to write my same 2 equations that I had before. 16 equals ab squared and 256 equals ab to the 6th. Now, when I use substitution, I like to just take my equation with the smaller exponent. So that's going to be this equation here because 2 is the smaller exponent. And I like to get a alone in that equation. So when I do that, this equation turns into, just like it did before, 16 over b squared equals a. And now I'm going to take this value here and I'm going to substitute it in to this equation. Whoops. I'm going to substitute it in to this equation here for a. So here's what I've got. 256 equals 16 over b squared times b to the 6th. This now gives me 256 equals 16 b to the 6th over b squared, and I'm going to simplify my b's. 16 b to the 4th. And you should maybe recognize once here I divide both sides by 16, you'll notice I have 16 equals b to the 4th, which quite honestly looks quite a bit like what I have here. So as you can imagine, if I continue on in this problem, I will end up with the same answer. And as you can see, here we are once again, same exact equation I got the last time. All right, last but not least, and quite honestly, the method that most everyone uses all the time, I'm going to show you elimination. Now, keep the following in mind. In completing problems using exponential functions involve multiplication. And the process that undoes multiplication is division. So if you think about it, when we're doing linear equations, when you use elimination, you're adding the equations together, right? But now, in this situation, in elimination method for exponential functions, the functions, things are being multiplied. So the elimination method here is going to use division as a method to undo or eliminate a variable. So same 2 equations that we've had. 16 equals ab squared. 256 equals ab to the 6th. All right, now, the method for using elimination is the following. The first thing that you always want to do is find the larger exponent. Okay, the larger exponent, 6. 6 is the exponent, right? So that means the first equation that I want to deal with is 256 equals AB to the 6th. So I'm just going to write that equation. 256. And I'm going to have AB to the 6th. Now, I am going to take that equation, because it's the equation with the larger exponent, and I'm going to divide it by the other equation. Now, be really careful. You cannot draw a line like this. I will mark this wrong all day long. You cannot divide equal signs. So when you do this, you're dividing 256 by 16. You're dividing AB to the 6th by AB squared. If you have one solid division bar, I'm going to deduct points. Okay, now that I've said that. All right, now the reason this is called elimination is because right here, friends, these two A's eliminate each other. A divided by A is just 1, so that goes away. Now, 256 divided by 16 leaves me with 16. And B to the 6th divided by B squared, at this point we all know, leaves me with B to the 4th. And once again, I'm at this familiar position. We've been here before. This is our third visit. I'm going to take the 4th root of both sides. The 4th root of 16 is 2. The 4th root of B to the 4th is B. No surprise. One final time, I'm going to take that B. I'm going to plug it in. I'm going to go back to the smaller equation. 16 equals A times 4 divided by 4. Once again, A equals 4. Again, Y equals 4 times 2 to the X. So like I said, any system of equations can be solved using any of these three methods, okay? They all obviously work. They all obviously give you the same result, but the most efficient way, and in math we love to do things efficiently, the most efficient way is elimination. I would say the second way, and oftentimes the way a lot of students prefer, is substitution. But again, do what makes your heart happy, all right? All right, here we go. There are 2 problems on the next page, and I would like you to try those. And again, you may use either equal values, substitution, or elimination. All right, here we go. Use any of these 3 methods, equal values, substitution, or elimination. The first problem asks you to find an exponential function that passes through the pair of points. All right, so for A, the 2 equations that you're going to want to start with are the following. -2 equals A, B to the -1. And -162 equals A, B to the 3rd. All right, go ahead and start this process. Again, you can use, and I want you to find the equation here. All right, go ahead and do that now, please. Pause the video so you have an opportunity to do that. All right, so hopefully so far you're doing well and you've gotten a value of 3 for B. All right, from here, hopefully you got an A value of -6. Now, some of you may have tried to plug your B value into the equation up at the top. Here, the -2 equals A, B to the -1. This problem you can still do using this top equation. It just makes it a little bit more complicated because you end up with 3 to the -1, which is 1/3. And then to solve, you have to multiply both sides by 3. But hopefully, even if you did that, you should be able to solve. All right. Let's look at B real quick. I'm going to set these two up, and then I'm going to set you on your own. So here we go. 1.75 equals AB squared, and 28 equals AB to the -2. All right, pause this video, go ahead and solve it. Let's see what happens. All right, you can see here, I chose to solve this particular one using substitution just to give you, something different to look at to see how it works, in case that's what you want to try. Hopefully this was successful for you. Also, just know, you guys all know we're going to practice this some more, so don't panic if you're still struggling a little bit. All right, really proud of you guys. Have a great day.